Before we get a discussion on blood types, let's review what we know about blood types. According to the textbooks, about half of the volume of blood is made up of blood cells that begin as stem cells in bone marrow. And these stem cells can develop into any of the other kinds of cells found in blood, including red cells, white cells, and platelets. So, some stem cells become white cells or leukocytes, and these are essential to the immune system. And when bacterial germs invade the body, some of the white cells form antibodies to resist infection directly, or the white cells begin to work on the chemistry of this foreign substance itself to fight the infection. Now, compared with the red blood cells, there are relatively few white blood cells, only about 1 for every 700 red cells, and the smallest of the blood cells are called platelets. But what they don't have in size, they make up for in numbers. Well, most of us have about 2 trillion of them, and they work to help the blood to clot and repair holes in the walls of blood vessels. But we need a way to transport the blood, right? Plasma is a liquid substance that transports most of the chemicals, vitamins, minerals, red blood cells, or erythrocytes. There are the most numerous, as I mentioned before. There are about 700 to every 1 white blood cell, so the red cells give blood a color red. How they're important for what we call blood typing. And blood typing is what I want to get going on today. Now, blood types are a classification of red blood cells according to presence of specific substances, genetic protein, and carbohydrate. And you can see them on the right. The 4 blood types are identified by letters A, B, AB, and O. Blood type A contains red blood cells with the antigen A. Blood type B contains red blood cells with antigen B. The AB blood type contains both antigens, and the O blood type contains no antigens. But the individual with this type can form antibodies containing either A or B antigens. Excuse me, is that why the O blood type is considered a universal blood type? Because antibodies with the A's are B antigens right here. But in type the blood antigens are really much more complex than this explanation might suggest. There are at least 300 different antigens. In fact, there are so many potential combinations that an individual's blood type is almost as unique as a fingerprint. But anyway, these basic types are used for determining compatibilities for blood transfusions. Before the transfusions to rule, hospitals always perform procedure called a cross-match. First one. Well, many minor reactions can occur, like refusal to choose so severe that I read a spontaneous reaction of the red blood cell for the donor, and that can result in shock or even death. So you can understand why blood typing is so important. Cross-matching lowers the risk of serious reaction. Okay, in cross-matching, we take red cells 1% plasma close and to negative response. Take a look at this diagram. It's on page 112 in your textbook. Here's what you'll be looking at with a reaction caused by incompatible blood. See how the cells clump together? The reason that this is happening is because there is a chemical reaction between the protein molecules in the blood cells of one person and the plasma of the other. Now look at this slide. This diagram is on the next page in your next, and this shows a compatible match with no clumping. See how the cells is evenly spaced? Well, of course, doctors prefer to use the same type as that of the patient in emergencies. Type A patient can receive type B blood, and type B patient can receive type A blood. But back to your question, since an O donor has blood type antigens, it's the ideal, or as you said, the universal donor. In an emergency, type O blood can be used for patients of all blood types, and fortunately worldwide, type O is the most common, followed by type A. Relatively few people have type B blood, and the fewest have type AB. Professor Stevens? Actually, scientists have developed artificial blood that's been used successfully in transfusions with human patients. It's a fluid, chemical stimulus. Fluid can be used as much as all blood types, and so the cross-matching steps in transfusion that can be eliminated. So far, artificial blood has done a good job of replacing the red cells by carrying oxygen through the body and eliminating carbon dioxide. But there are no white cells present, no antibodies, no platelet, so it doesn't clot, and it doesn't remain in the body very long. Still, continuing research along these lines should probably be encouraged. Even with cross-matching and other precautions, transfusion with human blood involve risks.